Good afternoon, everybody. The aim of my presentation today is to try to highlight the most important factors for a successful InSAR monitoring program. So I will briefly present our company, but I will immediately after try to cover the most important factors, elements, whatever, for a successful InSAR monitoring programs. And then I've tried my best to come up with some recommendations and conclusions. As you will see, this presentation won't be focused on ALOS-2 or ALOS-4 data only. I'm trying to cover a broader, say, a wider variety of SAR data, because depending on the applications, you need specific SAR data to get the best out of satellite SAR systems. I don't want to spend too much time on this, but of course, I want you to know that Thierry Altamira is very much focused on InSAR, so interferometric synthetic aperture radar. Personally, I've been working on InSAR for more than 30 years. I generated my first interferograms in 1994, so this year I celebrate 30 years of InSAR. And as my wife would say, InSAR is the only thing I can speak about. So I'm here to speak about InSAR. In terms of experience, Thierry Altamira was founded more than 20 years ago, was March 2000. Now we are more than 120 people. And so I say this not to self-celebrate, say, our company, but to pass you the message that indeed SAR data can create applications. SAR data can create solutions for final users. And indeed, if you even just go to Google Scholar and you try to find out the number of papers containing the word InSAR, it's incredible how really fast is the number of paper based on InSAR data. So InSAR is gaining momentum, and it's probably the reason why I would recommend you to spend some time to at least read a tutorial and learn how you can use InSAR data to solve real-life problems. InSAR, first of all, is a multi-scale technology. This is something I like highlighting because you can go from continental scale, and we are now involved in this great project aiming at mapping the whole European continent. And we started this 4 years ago. And now over Europe, there are InSAR data available for everyone. Okay, so if you are interested, you just have to type EGMS, European Ground Motion Service, InSAR data, and immediately you will find the right website. Again, you can go from continental scale, wide area mapping, down to a national database or a regional analysis. And this is something really becoming very intriguing and interesting. It's related to the monitoring of individual buildings. Probably you want to know about your own house, whether the house is stable or not. I mean, we are not there yet, I would say, but we are getting close to it with very high resolution SAR data. So in terms of key elements, personally in this presentation, I will focus just on the space segment, so the data acquisition, but it's important to highlight that you need good algorithms. So a key element is data processing. Then you need good visualization tools and also a good customer support group. Because nowadays, people are not very much familiar with SAR data. So you need to have people ready to explain and answer the questions of the final clients. In terms of data source, for InSAR, we need this list of requirements: a stable orbit, a stable attitude of the platform, a regular acquisition programs, low number of missing acquisitions, and possibly data redundancy. And this is key also for space agencies, because if you want to run a monitoring program, one single data source is not enough. And I know SAR machines are expensive, but for final users, they want to be sure they can rely on satellite data. And if they are aware of the fact that you have just one single data source, I mean, all the monitoring program immediately becomes shaky. Depending on the application, we can have many constraints: spatial resolution for sure, the satellite repeat cycle, so the temporal frequency of the acquisition, and in some applications also it's important to carefully select the polarization of the wavelength. But in general terms, I think that for final users, the most important factors are the regularity of the acquisition and also, again, temporal and spatial resolution of the data. Another key element, to be honest, is of course the price for at least commercial applications. In the present scenario, since we are working with all civilian data sources of radar data, we have X-band, C-band, L-band data. Very soon we will have ALOS-4 fully operational, but it is a fact that we can already today rely on at least 3 different frequency bands. And that's important because depending on the application, you can play or task with a specific frequency band. I see 2 trends now in the space sector. The first one is typical, okay, is technology-driven, is what the space agencies are doing, trying to cover with very powerful and expensive machines, try to cover a global acquisition scheme, okay, and try, of course, to increase the amount of information you can pass to then research institutes and in general final users. So you want to cover wide areas, okay, you want to have global coverage, and you try, of course, to increase the number of applications based on your data, okay, to justify the investment also. The second trend is something not pushing for the global coverage, but trying to have high resolution data covering specific areas of interest. Okay, so think about the difference between ALOS-4, okay, InSAR in the near future, or Sentinel-1 by the European Space Agency, and what Capella Space, Synspective, Umbra, and all these different companies are now trying to commercialize. all these companies are pushing X-band high-resolution data characterized by very short repeat cycles. And that's good because you see the complementarity between these two trends. And we need different frequency bands and different data sources because depending on the application, as I was saying, you can rely on different sensors. You see here the difference between Sentinel-1 data and TerraSAR-X high-resolution data for urban monitoring, or the difference between Sentinel-1 and ALOS-2 data, which can be extremely important for monitoring non-urban areas because you have a better penetration into the canopy. So in terms of future of L-band data, many people are now discussing about the potential impact of InSAR because it's specifically designed for InSAR, global coverage, 12-day repeat cycle. So we expect something important for InSAR, but there is a big but. There is no redundancy of the data. Once again, if you start a monitoring program based on this machine, unfortunately, there is no InSAR-2, okay? So as soon as you have a failure in the system, the monitoring is done. So, of course, you can think about tasking other data, other sensors, but so far, we don't have a constellation. So, coming to my personal recommendations, in my opinion, there is no silver bullet in radar applications. So we need L-band, we need X-band. There is room for, of course, commercial, cheap constellations of X-band data. And tomorrow will be, I'm sure, C-band and L-band. But I don't think InSAR will be a sort of winner taking all. InSAR will play a role, but there is room for absolutely ALOS-4, there is room for SAOCOM, and there is room for other sensors, even just focusing on the L-band data. Then a key point for a successful monitoring program is the regularity of the acquisition. So it's very important to know in advance the acquisition program. And I would say that it is wonderful if you can build a 14-day repeat cycle, consistent 14-day acquisition or revisit time over Japan along ascending and descending orbit with the ALOS-4, because I'm sure this can create a wonderful database of data, opening the door to many applications. I would recommend whoever will be in charge of data distribution, there should be special pricing for InSAR applications because it's completely different to buy one single image rather than asking you to acquire over a certain area and of course buy 40 or 50 different SAR images. And I'm very much intrigued by the possibility to combine right-looking and left-looking data. Say InSAR is left-looking, ALOS will be right-looking over Japan. And so this will enhance the possibility to discriminate also north-south displacement components. So my conclusions are the following. Please be aware that there is a growing demand of SAR data. Okay, we are not close to the amount of data requested to say that whoever is in charge of acquiring optical imagery, but the number of users and applications is growing steadily, and there is no one-size-fits-all solution in InSAR applications, and to me it's really important that everyone should be aware of the importance of data continuity. When you start getting missing acquisitions, it's bad. In Italy, you know, we have a Cosmos Skymed. The Italian Space Agency invested billions, and it's good, okay, it's good, but it's a dual-use constellation, and sometimes we have a special requests from our army, and of course makes sense because it's dual-use constellation. But this is creating data gaps for civilian applications and the monitoring, for example, of landslides in our country. So data continuity is critical, and I really hope that no one will consider a competition the two trends I've tried to describe in previous slides. So we have global coverage with the expensive machines, okay, financed by international or national space agencies. And that's great. And based on these, I'm sure there will be commercial companies investing for a constellation not aiming at covering the whole globe, but trying to monitor specific assets. And the synergy between the two is something we should all think about. So you can think about a general early warning, okay, of ALOS-4, based on ALOS-4 data, and then you can increase the number of acquisitions over a specific area thanks to data provided by Synspective, for example. So I really think we need a synergy between the two, and we should not consider these two families of sensor as competitors. Okay, that's all from my side. Thank you for inviting me.
Thank you for your presentation, Dr. Feretti.